Today you're going to be working with combined transformations. So consider the parent functions below. We're going to use the tables to sketch the graph. You should be able to plot the points and sketch the absolute value graph as well as the quadratic parent function graph. So it says we know how to transform these parent functions, but what happens when two or more transformations are done to a parent function? Do you guys think that the order in which the transformations are done are going to matter? So let's find out. Okay, we got two parent functions that are shown below, and if you see, they're different family members. So I have a lot of examples of absolute value and some different examples of quadratic examples. So on the pages that follow, you're going to be asked to do a few things. Number one, it says predict how the graph of each transform function will differ from the graph of its parent function. Number two, we're going to graph each transform function along with its parent, and we're going to record the observation. Number three, we're going to compare the observations for the transformations of y equals absolute value of x and y equals x squared. And then lastly, we're going to record any observations that appear to apply to both families of functions. So what I want you to do is turn to the second page. I'm going to work an example with you. If we look at problem number one, if you notice we have a few columns. We have the parent function for y equals absolute value of x. We have the parent of y equals x squared. We have the prediction of the effect on the graph. Then we have the graph of each with its parent graph, and that's the black graph that's already drawn for you. And then what is the actual graph on the effect and what is common to both families. So let's look at this first example. I have y equals absolute value of x minus 3. I have y equals x minus 3 squared. Now here the prediction of the effect on the graph, guys, I want you to guess. Before we actually come up with what the correct answer should be, we're going to guess. So if you look at what the example says, it says, I think there will be a shift 3 units to the right in the graph. So here's what we do. We're going to plug both of these equations into y equals. Remember, when I go to my calculator, I type in y equals. I'm going to type in both graphs. If you forget how to do the absolute value sign, I want you to hit the math button, scroll over to NUM, and ABS is your absolute value. Once we plug both of those equations in, I want you to hit graph. So now here's where I'm going to look at the graph of each parent function. Once you have sketched the graph, you should be able to notice that the graph did indeed shift 3 units to the right. So on my far right-hand column, it says, what is the actual effect on the graph? We're going to tell it that the graph shifted right 3 units, or 3 units to the right. And was it common in both families? The answer would be yes. Both of my graphs actually shifted 3 units to the right. So what I want you to do is go ahead and attempt to work the next 8 examples. You should remember how to plug absolute value into the calculator. If you forget, guess what? I said it on the recording, so go back and rewatch the video. If you have any questions, again, we will answer them in class, and then we will work another worksheet separate and similar to this in class. Have a good night.